The 390 millisecond speed limit. SUI recently achieved a consensus finality of 390 milliseconds, effectively reaching the physiological limit of human perception. This speed is not a marketing figure but the result of the Mysticeti protocol moving from the older Bullshark engine to a new uncertified directed acyclic graph architecture. By eliminating the need for validators to sign every individual block before it enters the graph, SUI has managed to slash latency by 80% while maintaining a theoretical throughput peak that reached 6 million transactions per second in recent July stress tests. This level of performance shifts the bottleneck of the user experience away from the blockchain itself and onto the speed of the local network connection and the wallet software. The Uncertified DAG Mechanism. The primary engineering breakthrough in Mysticeti is the removal of the certification step for every vertex in the directed acyclic graph. In traditional DAG consensus, a validator must wait for a quorum of signatures to certify a block before it can be used as a reference for future blocks, a process that inherently adds multiple round trips of network latency. Mysticeti bypasses this by allowing validators to build upon uncertified blocks immediately, using a new commit rule that determines finality through the graph structure itself, rather than explicit votes. Think of it like a relay race, where runners can begin their leg the moment they see their teammate enter the exchange zone, rather than waiting to physically grasp a baton. This architectural choice minimizes the idle time of the CPU, but it places an immense burden on the validator to process a continuous, unbuffered stream of incoming data. Complexity in the stability tax. This extreme performance comes with a significant infrastructure trade-off and a high degree of protocol fragility. To maintain sub-second finality in 2026, SUI validators are now recommended to run 24-core CPUs and at least 128 gigabytes of RAM, a hardware tier that effectively bars smaller operators and pushes the network toward professional data centers. The complexity of this consensus logic was laid bare in late May 2026, when the network suffered over 15 hours of downtime across 2 days due to bugs introduced during a software upgrade. These incidents highlight that while the DAG shortcut offers speed, the interdependencies within the code make the system more susceptible to cascading failures when state synchronization or randomness protocols drift even slightly from the expected parameters. The signal under the noise. The deployment of Mysticeti reveals a fundamental thesis in blockchain design, where user experience is prioritized over the decentralization of hardware. By hitting the 390 millisecond finality mark, SUI has functionally solved the latency issue for consumer applications, but the recent outages and the rising validator specifications suggest that this performance is currently being subsidized by an increase in system fragility. The shift toward uncertified DAGs represents a move away from the slow, deliberate security of traditional proof-of-stake and toward a more aggressive, hardware-dependent model. For builders and analysts, the real story isn't the headline transaction count, which recently crossed 4.5 billion. But rather how the protocol handles state growth and archival costs as it continues to run at these speeds. The next critical indicator for the network's health will be the implementation of confidential transactions on the mainnet, which will test if the current sub-second consensus can maintain its latency while handling the added compute overhead of zero-knowledge proofs. Subscribe for more